and all my kids are sleeping still.
Nice.
Yeah.
Nice.
Sleep? What's that? Okay. Um, okay, so Sherry, you did 1 and 2, so now we just need to do part 2.
Uh, what do you mean 1 and 2? Is that 2 questions on that thing? Yeah.
Oh, you did part 1,
Yeah.
1 and 2.
Yeah. So if we can do part 2, because I need
Okay.
going through it.
Okay. Yeah.
We need to go
Oh
back
my gosh.
to the crocodiles.
Yeah. So it's the crocodile data again. So the first one you do a test with the um, with the head and the body. So you're trying. So that's similar to the last lesson we had, where you're just looking for that linear relationship between the head and the body in the scatter plot.
Um, where is the crocodile data at?
Uh, the gargantual.
Oh, maybe I'm looking at
It's in the data files.
here it is. I'm gonna just go ahead and open this sucker up. I'm gonna try to make that class meeting on Wednesday. The game starts at it starts an hour earlier, so I may, in theory, be able to make that game. I'm like, or that I'm so tired of making games. Make
For
that
Wednesday.
for
Yeah, 4:30 for you and 5:30 for us.
yeah. So my game may be over by then. It's just a matter of whether I get back home. Okay, so I open this up, and I have my regular data. So this is check the 5 assumptions for conducting a linear regression on the data. List the 5 assumptions below. Explain how you calculated the assumption. So we're not doing predictive in this, correct?
You kind of are. You'll want to do it from the beginning because
Mm-hmm.
then it'll make it easier where you can just pull everything up all at once instead of having to go back and forth and back and forth. So your X would be your head and your Y is the body.
Okay, but right. But what are we trying to predict?
So you'll eventually predict um, the
Okay,
body, the head, or the size of the head according to the body. That's what it is.
I thought it was opposite, the size of the body depending on the head.
right.
Okay, the linear relationship between the head and the body length. Yeah.
Yeah. But this doesn't give us like that extra number to throw in there to do the predicted one, right?
Yeah, you're not doing the predicting just yet. You do that. Oh, you don't do that on this one. You do it on the homework. Sorry.
Okay, so let's start with the very, very beginning. So,
Okay, so first things first is you need to make sure that that has all the requirements met, and that's what number 1 is asking. You can't check 4 and 5, so you're basically just doing the first 3. So you do the two, so you'll have to do the regression, uh, linear, um, to do the RES underscore 1. So that's one of the things you do, but for the first one, you'll
mhm.
do the linear relationship between the head and the body.
So we need to do a scatter plot,
You do
correct?
a scatter plot, right?
Graphs, see,
And
scatter.
make sure it's a hot dog or a cucumber shape.
So the Y is my body,
Yes.
is the head. There's no up on this second, right?
Mm.
So there's my scatter plot. And
And it should be a pretty good hot dog shape, or cucumber, however you want to put it.
good enough. Okay, so the error, now the next one that is the error term.
Mm-hmm.
So
The error you use the QQ. So first things first is you need to make sure you do that residual thing.
okay, and so how do we do that again?
So you go to linear regression, linear statistic. Is it plots or statistics?
Linear. Okay, and so then the dependent is the body. Independent is the headline. And then I go statistics.
Did it bring up that predictor, the residual, or a smaller box? You might. Oh, it's save. Oh, go to save. Sorry.
Save. And then I go unstandardized.
Mhm.
And
And you can do both of those.
unstandardized, correct? Seems like there was
And then
something.
click OK.
No.
And then you go descriptive statistics to explore.
Hold on. I've got this whole regression thing popping up. Then I go analyze descriptive. This is the freaking problem. There's too many.
Yeah, it's literally a 3-4 step process.
Unstandardized residual. Is this where the
You put that one under the residual. Make sure you click on plots
hold on.
and check the normally something box.
Okay, hold on. I'm gonna get out of this thing. So I go analyze descriptive statistics, and I still do the unstandardized residual goes in my dependent, correct?
Mm-hmm.
And that's
Yep,
it.
that's it.
Statistics.
And
Continue.
then go to plots and make sure you check that normality thing, that box, that middle,
Okay.
and it should give you your QQ plot.
Um, I have a couple of things. I have a normal QQ plot of unstandardized residual.
That's what you want.
And then I have a detrended normal QQ plot.
Yeah, ignore that one.
Okay.
Remember, we don't mess with that one. We just do the first one.
Okay.
So the first one is the only QQ plot that you need to worry about.
Okay.
And that one should be pretty close to linear.
Right. Yeah, that's pretty good.
And then the variance, you go back to the scatter plot and you take out your, I think it's the dependent that's on top, and put in the residual. You change that. And then you do a scatter plot for that.
So take out the body length, but I leave the head in, correct?
Right.
And put in the residual.
And you're making sure there's no megaphone in that scatter plot. So that one will be all over the place. You're not looking for linear on that one. You're just trying to make sure there's no megaphone.
And I have no megaphone on that one. Okay. Good grief. Okay.
Yeah. So it's 2 scatter plots and 1 QQ. That's it. That's what you use to check it. The,
I'm probably got most of the day off because this is really confusing. Okay. So, okay, so it says test if there, so we can't do anything with D and E? Or what?
no. Yeah. No. You don't. There is an explanation on the thing, but according to the chart, there's nothing. You can't really check it.
Right. Yeah. Okay, so it says if there's a linear relationship between the head length and the body length, state the null and alternative hypothesis. So you don't want B1 or B1 0 and then B1 is not 0.
Yeah. So beta naught is equal to, or beta 1 is equal to 0, and beta 1 is not equal to 0. That's the hypothesis for this.
Okay. So watched him do a video where he did these plots and he got like literally everything, but I didn't take notes on it. I need to go back. Oh, maybe they all are.
Yeah, you should have those because when you did the residual, it'll pull it all up.
Let's see. I do. Okay, there's the T. Okay, I have the T. And then my p-value is 0. 0, 0, 0, 0.
Yeah. So your test statistic should be 22.675.
Great.
Okay. And then your p-value, when you click on it, it's 5.08 to the 10th, or to the power negative 13. So yeah, so 0.000. So, and because it's small, it's smaller than alpha, because there's nothing you can do with B,
Right.
part 2, you reject the null.
Okay.
And then
did we
E,
do a for this?
yeah. What?
Okay, well, it's wanting to know the confidence interval, and I'm wondering if this is the same as what's on this descriptive. No, it's not.
Yeah, this one, you can go back to the first scatter plot, and you can click on the confidence level in there in statistics. I usually do that, so it adds another box to the end of my coefficient and puts it on there.
Okay.
So.
We do that though. Analyze.
And make sure when you do it, it's just the head and the body. It's not the residual in the X or Y axis. So it's the head is the X and the body is Y.
It's not working.
You have to click on the statistics box and click on the confidence level.
Okay. And I don't have that anymore. I clicked out of it when we went back in. Okay.
I'll be right back.
Hey Cassie, did you do all of this? Does this make a lot of sense to you?
I did some of it, not all of it, but I'm just going to go back and figure it out because it was a little confusing. Like I wrote down all of the notes from the videos because I watched the videos, and I think I got it.
Yeah, that's what I'm going to have to do. Because he went through, and I was watching a video when the call came through, where he went through and he like click, 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 and he had everything.
Yeah.
Oh, shut the back door. How did that happen? Did that one work?
Yeah,
So,
he went through the QQ plot thing really, really quick, but
yeah.
everything else was, I kind of already done it. All right, so did we figure out 3, or are we still there?
I don't know how to get the confidence interval. I'm like lost.
Okay, so go back to, so do analyze,
Mhm.
regression, linear,
Okay.
do head as X, so head as independent, body as dependent.
There we go. I found it. Confidence intervals right there.
Yeah.
I should have clicked that originally. He does that. Giving me. I'm confused though, Justine. Um. Okay, that is the regression. Okay. We don't need the other stuff on that, right?
No, go down to the coefficient box and use the top line.
Okay.
So it should be 6.704 and 8.096.
Okay, I found them. Okay, sorry. I just needed to see that. Okay. Okay. We're good. We can take that. Guys.
Cassie, did you get my emails?
I did, and I got the one with the null and alternate that you'd sent as well.
Yeah, okay, good. Because while I was doing the PowerPoint last night, I was like, she needs these.
Yeah, I'll probably get on that tonight since I don't work.
Yeah, because as soon as you're done with that, I can put that into the PowerPoint and we're done.
Perfect.
So, and I'll send it to you guys before I submit it so you guys can look over it. But I think it turned out cute. Like I used the little owl from the Tootsie Pop. You know how many licks are in a Tootsie Pop roll? On the first page.
That's cool.
Yeah.
Brush your teeth, please. Okay. Okay, I'm ready.
Okay. Are you ready for the quiz, Cassie?
I am.
Okay. All right. I already pulled up everything. And I made sure I opened the group quiz this time.
What? Okay, the math one. Okay, so we get which chart we're pulling up.
All right. So the first one is, or first one, number 3 is C. So where beta naught and beta 1 are unknown.
Right.
So,
Okay, so residual is
Okay, it's not the first one.
the residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line.
So it's the second one. It's B. Is the difference between the observed value y and the predicted and the value predicted. So yeah, so x and y. Okay. A plot of residuals supports using linear regression when
What? Too many words.
okay, so it's not C because C is bad.
Would it be the first one?
I'm reading and looking. So curvature.
So like a scatter plot, maybe? In fact, I just say a plot.
No, that's for the
Say everything's used though.
Oh, I'm not liking this. Okay. Plot of residual support using linear regression. When you see a pattern, residuals are all positive. You see in megaphones. Okay, I know for sure it's not C.
The QQ plot of residuals.
The residuals look normally disputed with the zero mean. It's got to be that one. Because when you're looking at the residual, you're looking to see if they're spread out all over the place without a megaphone. And so when they're spread out all over the place, that means they're close to zero. Right?
The plot of residuals support.
Because I have, in my notes, I put to determine if it's normally distributed.
Which one do you think, Justine?
I think it's the last one.
With a zero mean?
Remember, when it's zero mean, when it has a zero mean, it is spread out all over the place.
I just don't remember them saying anything about a zero mean in.
I know.
Which one?
Okay, hold on. All right, so we're checking the plot of residuals supports using linear regression. Then make a residual plot. It could, yeah, maybe Cassie is right. You see a pattern in the residuals.
Hold on, no, it says if the linear regression is appropriate, then the residual plot will show no pattern and will consist of random scatter. It says if there is a pattern of the residual, prediction is not appropriate.
And it has to be the last one.
We're even without a zero mean. The residual is random standard. If there is a pattern in the residual, it suggests that linear regression is not appropriate.
Ah!
I don't have a clue.
Okay, well, let's just skip it and then we'll come back. Which one is the explanatory for the math sufficient thing?
What? Compute the residuals use computed data. Use the confidence data. And
Nah.
okay. Compute the residuals. Okay, so here's my note. don't know. This is just so confusing. Look at the decisions. There's the confidence data.
Okay. Compute the residuals for the math. Okay, using confidence.
Data as the explanatory variable, and the score data as the so
Well, it's got to be a linear because it's not asking for anything else. All right, so let's do confidence is X and score is Y. And what do I get? I get a nice little hot dog, which means they're linear.
so score is the dependent, and the confidence is the independent.
Say that one more. Confidence is
The independent.
independent, yeah, and your score is your dependent.
How did you get a hot dog? Nothing. Ben? Ben, come on. Let's help Ben spray the chickens right now. So you got a plot. I didn't get a plot.
You have to do a scatter plot.
Okay, but it said the instructions. Well, it said. Oh gosh, dang it. Residual in the software. Use the confidence data. So to compute residuals, to find the residuals, you do analyze, regression, linear.
That just gives you the information. You've got to do the scatter plot to make sure.
Scatter plot, residual plot. So graphs, legacy, and go spray this chicken right now. No, the hose is out the window. This is too much. I can't handle. Graphs, legacy, 7. Okay. Is this the one though, Justine, where we use the unstandardized residual as the y?
No. That's for the variance. This one you're looking for the linear relationship between the x and the y. That's what they're asking. Which are the residuals?
It just says graph, right?
Yeah, just graphs, legacy, scatter plots, simple.
Okay. So I'm lost this week. I just feel like it's just too much. Report. A plot? Oh, okay. Compute the residuals. Compute the residuals. And the score data is based on what statement best describes the residuals? Heck if I know.
So it's the residuals form a linear pattern.
It's such a big fat thing, though. I guess that's where I get confused, because I think of it being linear as more of a straight line.
Right.
So
And
straight.
that's where it goes back to the hot dog or the cucumber shape. So they want it to be a big hot dog where you can draw a line through it.
Okay, based on the QQ plot for the results are clearly not normal. Like right speed. They look fairly normal then, I would assume.
Yeah, they are. They're fairly normal. There's a little bit of a curvature on the tail end.
Right, this is a bit thinner.
So, because this is a QQ plot, so I've already pulled up my QQ plot
Okay.
of the residuals. So this is where you don't do the score or the confidence, you just do the residuals. Gosh.
Okay. Use software to create a scatter plot. Isn't that what we just did?
Yeah, but there's two. Oh, that's all 5 of them. Are you kidding me? Okay, I've got to do one more test, and then it should be all of them. So I just have to do the scatter plot for the variance, but there's no. Yeah, it should be all of them. The X values are measured without error, and the observations are independent.
How do you know if they're independent?
What?
How do you know that they're independent?
Knowing the value of one of the Y's tells you nothing about the other points. I don't like that. And see, that's the part that you can't check. But because everything else falls into place, this should fall into place as well.
Well, I guess I go back because I feel like this is like so super confusing. It says knowing the value of one of the Y's tells you nothing about any of the other points, right?
Right.
So what could it tell you about the other point? Like, I guess because they don't show you an example of when that happened, I don't know. I wouldn't know it if it landed in my lap.
Right.
Like, I feel like this whole lesson is a hot mess.
Mm-hmm. All right. I think I'm taking out the Y and putting in the residual.
You guys, my stomach isn't feeling too good, so I think I'm gonna head out a little early today.
Okay.
Hot mess.
Okay. Bye.
Bye, Kat.
Bye. There's no megaphone on the variance scatter plot.
seriously feel like this is like a totally foreign language. I have no idea
I
what.
know, and I'm not
True.
helping very much right now. I'm sorry.
And it's not. It's too much at once, and it doesn't. The explanations are terrible.
Mm-hmm.
But there's no way to check the independence or the values of x. Like I don't know how you're supposed to, like, why do they even mention them if there's nothing we can do about it?
Mm-hmm.
I guess it just frustrates me. If you residuals,
All right, I'm gonna go back into the book
that's what I'm doing right
and
now.
see if I can find. Huh?
That's what I'm looking at right now.
The x's are fixed and measured without error. In other words, x's can be considered as known constants. Okay, not helping.
Okay, in this course, we will test if the true slope is different from 0. If the slope equals 0, then the regression line reduces from. Addison, I cannot right now, please, honey. Okay, have a good day. Real quick, what did they do without you?
Come on.
I don't know. Maybe we should just save this for later, and I'll go through and watch all those videos. And are you available today? Are you got stuff going on?
No, it's spring. It's spring break.
No plans though.
Why are you doing that? I'm gonna mark all of them.
Are you?
Mm-hmm. All right, I'm gonna go in here as my computer likes to freeze right now.
Oh, hold on.
So, bottom line. Okay.
The worst. Even the book's super confusing. The slope is 0.
Okay.
Which one's
So, go ahead. Which one's the slope?
right? When we look at
The
our
slope is the bottom one. In the B column, it's the bottom one. So the 12.695.
0.695. Okay.
And then 10 is the first one, the confidence interval.
Where's my confidence interval? I did the confidence interval.
Okay, it should be reject the null.
My confidence interval did not show up. And I know I clicked it. So we have to go analyze, regression, linear. Statistics. Oh, okay, there it is. 10.674 and the 14.715.
Yep.
Holy smokes. Okay, let me go back to the test. Okay. So what is B? The B1. So what did you mean?
For 11 or for 9?
9.
9 was 12.695.
And the confidence interval is the first one.
Uh-huh.
I didn't even look at what the p-value was. 60.
Yeah, it's super small.
So we reject the null is less than alpha. So the second one,
Yep.
for hypothesis B1 slope, if you reject the null hypothesis, what does it mean? Well, there's sufficient evidence to conclude the slope of the regression line is not 0, right? So the third one.
So is it not or is it is?
Is not 0 because the hypothesis is that it is 0. Right?
Okay. Right.
So we're saying not 0 because we are rejecting the null. Which variable is dependent? It should be the body length for 13.
Yep.
Says it's not containing variables.
I
So
think
for
it's I
first
think
one,
for 14 it's the first one.
yeah, that's what I was going to say. The other ones don't make any sense. And then we still have to
Because
go
I
back.
remember, yeah, go back in the book because it said something, the very last section, I think section 5.
Confidence interval. Okay, so in this case, just look for Yeah, they don't, it doesn't really say anything about the zero. I saw the zero somewhere, and I'm just not sure where. But it's not in that. It's just talking about being negative. You have to look at what the question is and make sure that it makes sense.
Just remember seeing
They said
something about it.
Yeah.
Okay, so yeah.
You think it's that first one?
Okay, so if it was 0.
Well, we know it's not. It's not. It's not the other two. Because you just have to read them. That has nothing to do with.
Yeah.
And it's never a
Well,
chance.
it doesn't. Okay.
Do you know what I mean?
Yeah, so the first one?
The only one it can be. I just, it's not a 99% chance. It's not.
Oh, yeah. Can't be, yeah. And it's not insufficient.
It has
So,
nothing.
because they're not asking about the p-value, they're asking for the confidence level.
The other two.
Okay.
So,
I'm going to go ahead and submit mine.
Hold on, we got to do
And
5.
if I get it totally, I already did, I put the last one for 5. Yeah, I did. So, because remember when we had to look at the scatter plots, what was it, 2 lessons ago, where it had, whether it's positive, negative, moderate, strong, weak, and the more scattered out it was closer to, but it was closer to 0, and that's where I'm just like, ugh. Because the residuals can be negative. They don't have to all be positive. In fact, half of them are always negative.
Yeah.
And we're not looking for, we don't want to see a megaphone, and we don't want to see a pattern. So the residuals are supposed to look normally distributed. So seriously, if I mess it all up, I can always just ask him to reopen it again.
I just don't remember them saying anything about a mean. Do you remember that?
Yeah, and I don't remember a mean either. Yeah, I don't remember a mean either. And that's where it's throwing me off, is that one little word, those 2 words at the end. But you're looking in the residual plot to see if it's normally distributed or not.
Well, it's that supports using that's throwing me.
A plot of residuals. Okay, so plot of residuals is you're looking for the constant variance. No megaphone shape in the residuals.
Right. No pattern. Well, and I guess it's the wording, because it says a plot plot of residuals. What kind of plot? A scatter plot? A QQ plot?
That's a scatter plot. Yeah, it's a scatter plot.
How do you know though?
Because it's in the chart. iPrep part 1 in the chart. The second one or the third one, it says constant variance. It's a residual plot. And when you're looking for the residual plot, it's a scatter plot.
Right, but I got that. I'm just wondering about the question. Just because the question says a plot of residuals. Is it only a scatter plot that does residuals? Or is there a QQ plot of residuals as well? Yeah, there is a QQ plot of residuals.
But nothing what they're asking for is a part of that QQ plot.
Yeah, it makes no sense. It's a stupid question. Residual plot is an omega phone. QQ plot, it says points in the QQ plot are close to the line. Yeah, whatever at this point, he'll always.
All right, I'm gonna hit submit, and like I said, if we totally mess it up, he'll let me get back in. I mean, all right, movie thing. All right, I have a B. So 5 is the last one. So I was right. The residual look normally distributed with the 0 mean. 6 is wrong, however.
Okay. Compute the residuals.
I don't like that one. That one's crummy. So this one, so 6 is the residuals are between -40 and 25. That's the answer to that one.
With numbers on it,
Yeah, we didn't do any numbers.
And what else did we miss?
Oh, so the last 2 on number 8, don't mark them.
Okay. Is that it?
Yeah, that's it.
Probably one of the worst worded tests. I'm going to print this out and make notes. That was horrible.
Yeah, 8 I should have known. Because when you're doing the scatter plot, the residual plot, and the QQ plot, those are the 3.
That's all you can do, right?
Right. So you're checking for the variance, you're checking for the residuals, and then you're checking for the linear relationship. You're looking for the first 3. I should have known better on those.
Oh. Okay. Well, I'm going to pull the rest of this stuff up and watch these videos and see if they help at all. Because this was horrible.
Okay.
Okay, well, I'll be home today if you need to check. It's supposed to be cold tonight. I'm wondering if I can get out of working tonight. It's only supposed to be like 69. So
yeah, well, it's been raining, and yesterday we woke up to snow on the ground. Welcome to spring in Utah.
Yeah, no kidding. We're like having a panic attack. It's only supposed to be a high of 69. And that's before it's been like in the 90s. So it's been really, really nice.
I'll love the 69 weather. Like me. Here, I'm gonna text Cassie really quick.
Okay.
I know she's not feeling well, but I need to know if Thursday or Friday works better. Does Thursday or Friday work better for you for this review? Because it's the last one we have to meet together for.
Friday, just because I've got to, unless I do it later in the day, just because my son has an orthodontist appointment at 8:30.
Okay. I'm gonna text her and see if she'll respond back. If I can spell.
Let me go grab my thing off the printer. I'll be right back.
Okay.
Okay. Did she respond to you?
Yeah, she said we can do Friday if it works best. So your son has his appointment at 8:15?
8:30 on Thursday.
Oh, 8:30 on Thursday. So we can do Friday. So Friday at 8?
Yeah.
So 7
Yeah,
your
whatever.
time?
I have
Okay.
no on Friday, so I'm, or if that's better for you on break, you know. What else?
It's more or less where she's at,
The early.
because I think she has to work. She has to work.
Okay. Okay. Yeah. Okay. Are you done recording so we can chat?
Yeah, let me turn it off. Hold on.